All right. Welcome everyone to another physics class. All right. So let's look at this question on the board. Now, this is a branch of physics called optics. So I think the past two classes we had, we talked about motion. So motion is another branch of physics we call dynamics. All right. Dynamics. All right. So this is optics. Optics and light. Optics, the aspect of physics that in short, the practical aspect of physics that deals with we have lenses, we have camera, we have mirrors or microscopes and all that. Alright, so we have a question right before us. An object 15 centimeter high is 30 centimeter from a pinhole camera. I know this may look strange to many of us. What is a pinhole camera? Now, a pinhole camera is simply a simple camera, right? Without a lens. Without the lens. Your normal camera possesses lens. I think as time evolved, so we started having cameras that possesses lenses. Then your phones also lens. The human eye also we have lens. All right. So, but the pinhole camera does not have a lens. It was used in the olden days, and how it is used is that it's like a box, something like this. Let me just give us a with a small opening. We call the opening an aperture, a small opening. So you have an object like this placed in front of the pinhole camera. The light rays fall on this object, and then there's a kind of a screen at the back of this box, so that the image formed at the back of the image is formed here, just the way the image is formed on the retina. The same thing with this pinhole camera. So you have something of this sort. Are we there? So when light rays passes through, you see we have this through this small opening. Through this small opening. Now, one thing you must observe is this: the smaller the opening, the more clear the image becomes. But if you enlarge this opening, you're going to have. Now, one thing is important. Those days when this camera was used, and it takes time before image will be formed at the back here, all right, because of this tiny aperture, all right. So it takes time. You have to wait for all this, every part of the image to be formed here. But if you want the image to be formed real quick, very fast, just enlarge this opening very fast. Image will be formed here. Now, but there are two challenges you're going to have. Number one, the image that will be formed at the back will be blurry. It will not be clear. It will be blurry. Okay, it will be blurry. So that's one of the disadvantages of the pinhole camera. It takes time, and also when you enlarge this opening, the image form will be blurry. Now, looking at this question, so we said the object is 15 meters high. This is the object, so 15 centimeters. The object is 15 centimeters high, and it's 30 centimeters from a pinhole camera. So the distance of the object from this point, from the hole, the distance is 30 centimeters. So this is the object distance. Let's call it OD, and this is the object height. We call it OH. Now we said if the height of the image is formed, at the back of the camera is 10. So the image formed at the back of the camera, the height is 10. Now note that, see the object form is standing upright, the arrow is facing up. Look at the image form at the back. What do you observe? The arrow is facing down. Now when that happens in physics, we call such an image an inverted image. We say the image is inverted. Now another case you can get this inverted image is when you start studying mirrors, mostly plane mirrors. Plane mirrors always produce inverted images. A plane mirror always produces an inverted image. Alright, so back to our question. So the height of the image form is 10 centimeters. Find the image distance. So the image distance, which will be the distance from here to there, let's call it ID, and this is the IH, the object height, the image height. Now all we need to do to get ID, the image distance, is to establish a relationship between these two. Now if you check, we'll just use a height, distance. That's all. So we can have object height relative to the image height, which is equal to the object distance relative to the image distance. Why is this possible? Because if I draw this diagram very well, you're going to see that I'm going to have something like a right angle triangle. So all we needed to do was to relate the sides. This will also give me a right angle triangle. It's just to relate the two triangles we are going to have. The first triangle to respect to the object, and the second triangle with respect to the image. So what I needed to do was to establish a relationship between the size of the object, the size of the image, and then since I started with object, the distance of the object from the pinhole, and then we relate that to the distance of the image from the pinhole. Alright, so let's put in our values and let's see whether we get the answer. So object height is 15, image height is 10, object distance is 30, image distance we don't know. So if we cross multiply, we're going to have 15 times your image distance equals to 30 times 10. If I divide both sides by 15, which is the coefficient of the image distance, by 15, I'm going to have 15 here, 15 can divide 30, and we have 2. So that our image distance will be 2 times 10, and that is 20 centimeters, which is option A. So please like, share this video to students that have any issues with this aspect of physics called optics. Subsequent classes will delve more into optics, alright? And I believe it will be of great help to students. Thank you very much. See you in the next class.